Hey everyone, it's Ben from Board to Bits, and this is the second video in our series on saving game data. Today we're going to be talking about scriptable objects. So, the Unity API and documentation describes a scriptable object as a class you can derive for objects that don't need to be attached to game objects. They also say it's useful for assets that are only meant to store data. I like to think of them as kind of like this uber variable, where in a normal class you can put in an int or a string or a vector3, things like that. With a scriptable object, you get this mega variable that you can add instead that has all of the information you need. Another way of looking at scriptable objects is to understand that with Unity, everything is an object, and monobehaviors are one type of object. Those are the ones that are in your scene that you can move around with a transform, that you can affect with updates, with frame updates and things like that. Scriptable objects are like just data-only versions. They're like the cousin of monobehaviors, but they only contain data and they don't get involved in the actual game quote-unquote world. So some of the pros of scriptable objects: first off, they're built right into Unity, so they're very well maintained, and they're very well maintained, and you can interact with them very easily in Unity. They can also, one of the biggest benefits of them is they can be saved as assets. And what that means is that you can create a scriptable object, almost like a little mini file inside of your project, and you can update that and you can save that as you're working on your game. Another thing is that you can save them during runtime, so if you change something during runtime, it will actually remember that. There's a lot of frustration sometimes when you're changing the settings in a particular class or on a particular object, and then you stop testing your game, and all of those changes get wiped away. With the scriptable object, that doesn't tend to happen. It's also an internal solution for saving data, which means that when you are trying to get this data, when you're running your game, you don't have to worry about parsing external files, which will come into play more in when we look at things like databases and your own custom save files. In addition, you can save a large amounts of data. The documentation for Unity says that you can save like millions of ints inside of a scriptable object, so there's a lot of space there. You're not going to hit any kind of size limitation. In addition, one of the nice benefits is that as you're building a scriptable object, you might say, create a scriptable object and create a few instances of it, have a few assets of it, and realize, oh, I need to add this other variable. I need to add a name to this thing, or I need to add a new setting for move speed, or whatever additional variable you need. You can add that in and it won't disrupt your variables. Deleting variables won't disrupt your scriptable object, sorry. Deleting variables can have a little bit of a negative impact depending on how you're doing it, but you can add things on without fear. Some of the cons of scriptable objects: they do require editor scripting a lot of the time, especially if you want to make assets out of them. You have to know a little bit, so it's a little bit more of an intermediate solution. But it's not super complicated, and we'll get into how to do that in this video. Secondly, you can't edit any scriptable objects outside of Unity. That if you're just working in Unity strictly, that's not really a huge issue, but if you have like a team-based solution where you want to send a file to someone and have them edit that, or have it be a little bit more moddable, it doesn't really work because everything is contained within Unity itself. And lastly, you can't save during runtime once you've built the game, meaning that this is not a solution for saving a player's progress. This is really only for saving your game dev data, basically. I'm sure there's a better term for that if you guys know it and want to comment it in the video, but all I can think of is that the data that you're creating as you're developing the game, not the data you're saving from a player playing your game and making progress in the game. So things this is good for, as I just said, that sort of game development data, storing that kind of data for your game to be played, great for that. In addition, scriptable objects are really good for the fact that they kind of break your data into more sizable chunks so that you're not eating up a lot of memory. Part of this is that, say you have like 10 levels in your game. If you just have one class with an array of the 10 levels and the data for those 10 levels, that's going to all get loaded at once the moment that your game manager class gets loaded, say. However, if you have references to level data scriptable objects for each one, then you're only pulling in one at a time, and those references don't eat up a lot of memory, but you're only pulling in one full level at a time. So you're, like I say, you're breaking that up. You're not eating up huge chunks, you're eating more bite-sized chunks of memory with each level. So, Now that we've kind of talked about why you might want to use scriptable objects, let's talk about how you use scriptable objects. So now we're in a Unity project, and let's take a look at how scriptable objects can work. So I've got a very simple game here, where, not really a game at all at the moment, it's just a single enemy that's going to move back and forth across the screen. I'll hit play to kind of show you how it works. As you can see, he moves right a certain number of spaces, and then he bounces and starts moving back to the left, and just moves back and forth like this. It is worth noting, though, that he has a few bits of information here. He's got a name, Bill the Baddie. He's got a move time. This is every half a second he takes a step. And he's got a color. So let's see how that's working in our script right now. I've got all this information contained in a enemy move script. Jump over to MonoDevelop, and here we see that. So here are the public strings the public string, float, and color that you just saw. The string for the name, the float for his move time, and the color for his color. I also have some private gameplay data. And this is first a timer, and this is just going to control counting down that half a second in this case, or whatever I set my move time to. I've got this is the movement limit. He moves 5 spaces to one side, and then he bounces back and starts moving until he's 5 spaces to the other side. Technically a total of 10 because he's moving from +5 to -5. And then lastly, I have this bool just tracking whether or not he's moving left or right. That's just how I'm having the alternation script handled. This is where the real important thing here is this void start. Void start sets the name of the game object based on the string. It sets the timer to the move time based on move time here. And the sprite renderer of our component will then change its color to match the color that we set here. The rest of this all is really just to control the enemy during the game. I'll leave it on the screen for a couple of seconds if you want to take a look at it and just duplicate it in your game if you want to kind of follow along with this. But the important thing that I'm going to show you guys here is how to get the scriptable object set up. And this is just kind of an example game, very simple to kind of show how it works. Okay, so this information up at the top here, these 3 public items, are really that information that's going to define and make this enemy unique from other enemies. Maybe another enemy will have a different name, a different color, he might move faster or slower, etc. So this is the information that we could take, and instead of having it be in the enemy move, and we would have to make, say an enemy prefab and store that in there, why don't we just make a scriptable object that holds this information, and we can port that into our kind of generic enemy, and then that enemy will kind of self-customize to whichever enemy we want. So how we're going to do that is we're going to create a new script in our scripts folder, and we're going to call this enemy data. Open that up in MonoDevelop. And instead of inheriting from MonoBehavior, this is going to inherit from ScriptableObject. Now we no longer need start and update because scriptable objects don't follow the world rules of Unity. They're just storing the data. But we are going to put 3 things in here. We're going to say public string name, say public float move time, and we're going to say public color. This is all going to look very familiar because these are the 3 things that we had here. And now what we can do in our enemy move class is we can delete all 3 of these, and instead we can say public enemy data. Now we do have to make a couple fixes here because we're going to see there's a few spaces that there's no longer a move time variable inside of enemy move. So we need to make sure we say data.movetime and data.color. We also need to change this gameObject.name to be data.name because name is, we probably could have named this like enemy name up here because name is a inherited variable from any object has a name. So it's a little bit funky, but just make sure you put data.name here as well. Otherwise, it's just going to try and get the same name that it already has. And then lastly, we need to fix that here as well and say data.movetime in our update function. So now that we have all of these, we go back to our enemy we will see that instead of those three, the string, the int, and the color, we have this data slot for an enemy data scriptable object. The downside to this is that we can't just edit it right from here. We can no longer just put in the information right here. We need to have that object that we can drag into our game. However, how do we do that? Because we don't really have a way to make an enemy data object right now. We can make all sorts of other assets. We can create folders and scripts and scenes and materials. We can also, in our game, we can create game objects like, cubes and sprites and all this sort of stuff, but we don't have any way of making a enemy data object that we can then put into this space here. However, fortunately, the Unity community has already taken care of this for us. If we go online, and if you search, just do a Google search for create scriptable object asset. I'll put the link in the description of this video as well. You're going to get this page that has two scripts here. The first one is called ScriptableObject Utility, and the second one is called Your Class Asset. This first one, all you need to do with this, copy it all, and then create a new script in your editor folder. Make sure you create an editor folder, and create a new C# script called ScriptableObject Utility. You can name it something different, but if you do so, make sure that you're also renaming it in your class, because when I paste this all in here, you'll see that that's the name that it's using. Save that. And what this does, in a nutshell, is when we give this a specific scriptable object that we want, it will then make that into an asset for us. In the same way that when we create, say, a material, it appears in our folders here, this will actually create an asset that is a scriptable object. And then the second thing we need, and it's going to be again in the editor folder, we're going to do C# script, and I'm going to call this enemy data asset. Again, you can name this whatever you like. I tend to like to name it based on what the script is called, which is in this case enemy data, and then asset because we're making an asset with this script. What we do in here, we'll go back to this web page, and we're going to copy all of this. Whoops, not the header. Open up enemy data asset, and in here again we're going to copy or cut all this and just paste in our previous stuff. And here I'm going to change this. Anywhere where it says your class, you're going to change to the name of the class that you're creating. So ours is called enemy data. So I'm going to say enemy data asset. Enemy data. This you can actually name whatever you like if you have another name that you'd like for it. This is literally just what's going to appear in the menu. And then here, though, you do need to say enemy data, because this is where we're then passing in enemy data is the asset we want to create and telling the scriptable object utility to make one for us. So now, when we come here, I've also made this game data folder. I can go here, right-click, and now if I go up to create, there's this new option down here at the bottom, enemy data, and that's what we just added with those scripts. If I click enemy data here, we get a new enemy data. As we can see, it's got our name, move time, and our color, just like the enemy originally had in its class. I'm going to click here, just give it a quick name, Bill. Now you'll notice that naming it here does not actually affect the name here. So I'm also going to put in some information there, Bill the baddie. We'll give him a move time of ½ a second like he had before, and we'll change the color to just like a yellow, kind of a little bit darker yellow. And make sure you up your alpha all the way, otherwise you won't have anything up here. So now what we can do is if we go to our enemy class, we've got this slot for an enemy data asset, and we've got one right here. So we drag that into data, and now it appears there. We can hit play, and it takes on that information. It's moving every ½ a second. It's got the yellow color, and we see that his name is Bill the baddie. So this has all been kind of a roundabout way just to get to the same point of that we're just have this enemy here that has the same information, but we've added editor scripts and that. What's the benefit to us? The benefit is, say that we have multiple levels. In the first level, we're fighting Bill the baddie, but in the second level, we're fighting Sam the sub-boss. And third level might be, you know, Betty the boss. How do we may still want this exact same scene, but we want to just customize that enemy each time. And we can do that with our scriptable objects very easily. Instead of having to create multiple scenes with different enemies placed into them, we can do it all from right here. Let's create an empty object, and we're going to call this Game Manager. And I'm going to go into Scripts and create a Game Manager here as well. Open this up. And inside of here, I'm going to put a few pieces of information. I am going to put in a reference to our enemy. Now, typically in a bigger game, you're probably going to be like instantiating enemies and then giving them the scriptable object information. But for right now, we can just have a public reference to the one that we've got there. A little bit quicker. And we're going to say public enemy data. Make an array of those, and I'm actually going to call this level data though. And then I'm going to have a public int called level. I'm actually going to put in a quick attribute here. I'm going to say range 1 to 5. And all that's doing is saying that we can only go between levels 1 and 5 right now, because I don't want to accidentally put in a negative level or something crazy high and, you know, something that doesn't make sense. Lastly, with this, I'm going to say void start, so that when we start our scene, I'm going to want to quickly do two things. First, I'm going to check that our level is less than or equal to the size of our array, and if it's not, fix it, because I don't want to throw an error just because our array is too small. So level less than or equal to array size. And then from there, I'm going to pass the scriptable object info into our enemy. So for the first part of this, I'm just going to do a quick if check and say if our level is greater than level data dot length, then just set level equal to level data dot length. So basically it's saying if we're above our maximum, just go back to the maximum so that we're not going to have an outside of array exception. Once we've done that, we know now we're going to be getting something that's inside of our array. We can say enemy.data is equal to, and pass in whichever enemy data associates with our level. So we'll just say level data, level, I'm going to say -1 because we, of course, 0 index in an array. So if we're at level 1, we actually want the 0 position. Level 2 would be 1, etc. So now we can jump back to Unity here, add our Game Manager script to our Game Manager object. Make sure we're on 1. It defaults to 0, but once you start moving this around, you'll be limited to 1 to 5. And we can add, let's see here where we are, game data. We can add Bill to our level data. So now what happens, I can actually delete the level data from our enemy here. So now once again, it's just a generic enemy, has no real information to him. But I make sure I drag my enemy into the enemy slot of the Game Manager. And now if I hit play, Bill comes right back because he knows it's level 1. We should put in Bill's information. But now we can really show what the power of scriptable objects, because if I want to, I can create another enemy data. We'll rename this Sam. Say he's Sam the sub-boss. Give him a move time of, say, 0.35, so a little bit faster. And we'll give him kind of an orange, a little bit brighter orange color there. Now I can drag that in. Oops. Drag that to add another. If you drag into the name of your array, it will actually add it right to your array instead of having to change the size each time. And what we can also do is even duplicate this, for example. Now we have Sam1, but I'll call this Betty. We'll name this Betty the Boss. Give her a move of, say, every quarter second. And give her kind of a red color. And once again, we'll add this now to our data. So now if I make this level 3 and hit play, we're populating in that information of Betty the Boss instead of the information of Bill or Sam. So obviously this is a very simplified example of this, but once you get to things where you have, dozens or hundreds of levels, or you have, it's really good if you have a wide variety of enemies or a wide variety of items or something. It's also really useful if you're, say, procedurally generating a world and you're doing like a tile-based system. Instead of having every single tile have to retain specific information about itself, you could just give it an index and then have an index of all of your tile types and be able to pull from that, which is it's a huge savings for your memory, especially if you're just building the map right off. Then you don't have, and then it can just pull the necessary information when it needs it, rather than having a huge map that's storing, a bunch of different variables in every single tile. So one last thing I can quickly show you that we can do here is, like I said, we can also kind of edit our scriptable objects even when we've created a few of them. So like right now, we've already got 3 of these guys now. And it might be a pain in the neck. You think, oh no, I want to add something else. Like, let's actually go to our enemy data script, or our enemy move script, and we have this limit. Right now, everyone moves 5 to the right, and then all the way over 5 to the left, back and forth. But maybe I want to change that. Maybe I want that to change based on the enemy too. Well, we can certainly do that. I'm going to delete that, in fact, from here altogether. And in our enemy data class, I'm going to add another public int called limit. Save that here. And now, where we have this limit down here, I can say data.limit. Oops, not data.color, data.limit. And so now what it knows is, oh, I can just get the limit from the data and use that instead. So now if I go back here, say to our Bill the Baddie, and give him a limit of, he only moves 1 space to either side. Meanwhile, Sam might move 3 spaces, and Betty is the only one who can actually move 5. So I'll save this again. If I go to my game manager, go back to, say, level 2 now, hit play. Now we see he moves 3, then back 1, 2, 3, back 1, 2, 3, so on and so forth. We were able to add that, and it didn't affect any of our other information. It just got added right in there, didn't miss a beat. So this is, like I say, a very basic example, but kind of shows you the ways that you can use scriptable objects to store your information, kind of have a little mini database of your own, like these micro files that you can use, instead of having to worry about changing classes and making custom prefabs for every single variation. Instead, you can just create these data files that can populate into a sort of generic template that you might have. Now, obviously, if you want to be able to edit the stuff outside of Unity, this isn't going to work. Then you're going to need to get into either a custom save file and some sort of custom program to edit those files, or you can use databases like things like XML and JSON, which we're going to be getting into in our next couple of videos. So thanks for watching, and I will see you next time.